I'm going to talk today about energy and climate. And that might seem a bit surprising because my full-time work at the Foundation is mostly about vaccines and seeds, about the things that we need to invent and deliver to help the poorest 2 billion live better lives. But energy and climate are extremely important to these people. In fact, more important than to anyone else on the planet. The climate getting worse means that many years their crops won't grow. There'll be too much rain, not enough rain. Things will change in ways that their fragile environment simply can't support. And that leads to starvation, it leads to uncertainty, it leads to unrest. So the climate changes will be terrible for them. CO2 is warming the planet. And the equation on CO2 is actually a very straightforward one. If you sum up the CO2 that gets emitted, that leads to a temperature increase. And that temperature increase leads to some very negative effects. The effects on the weather, perhaps worse, the indirect effects in that the natural ecosystems can't adjust to these rapid changes, and so you get ecosystem collapses. Now, the exact amount of how you map from a certain increase in of CO2 to what temperature will be and where the positive feedbacks are, there's some uncertainty there, but not very much. And there's certainly uncertainty about how bad those effects will be, but they will be extremely bad. I asked the top scientists in this several times, do we really have to get down to near zero? Can't we just, cut it in half or a quarter? And the answer is that until we get near to zero, the temperature will continue to rise. And so that's a big challenge. It's very different than saying, we're a 12-foot high truck trying to get under a 10-foot bridge and we can just sort of squeeze under. This is something that has to get to zero. Now, we put out a lot of carbon dioxide every year, over 26 billion tons. For each American, it's about 20 tons. For people in poor countries, it's less than 1 ton. It's an average about 5 tons for everyone on the planet. And somehow we have to make changes that will bring that down to zero. It's been constantly going up. It's only various economic changes that have even flattened it at all. So we have to go from rapidly rising to falling and falling all the way to zero. This equation has 4 factors, a little bit of multiplication. So you've got a thing on the left, CO2, that you want to get to zero. And that's going to be based on the number of people, the services each person's using on average, the energy on average for each service, and the CO2 being put out per unit of energy. So let's look at each one of these and see how we can get this down to zero. Probably one of these numbers is going to have to get pretty near to zero. That's back from high school algebra. But let's take a look. First, we've got population. The world today has 6.8 billion people. That's headed up to about 9 billion. Now, if we do a really great job on new vaccines, health care, reproductive health services, we could lower that by perhaps 10 or 15%. But there we see an increase of about 1.3. We've gone from 26 billion to, at best, maybe 13 billion tons. And that just won't cut it. The microprocessor is a miracle. The personal computer is a miracle. The internet and its services are a miracle. So the people here have participated in the creation of many miracles. Usually we don't have a deadline where you have to get the miracle by a certain date. Usually you just kind of stand by and some come along, some don't. This is a case where we actually have to drive at full speed and get a miracle in a pretty tight timeline. Now, I thought, how could I really capture this? Is there some kind of natural illustration, some demonstration that would grab people's imagination here? I thought back to a year ago when I brought mosquitoes, and somehow people enjoyed that. It really got them involved in the idea of, there are people who live with mosquitoes. So with energy, all I could come up with is this. I decided that releasing fireflies would be my contribution to the environment here this year. So here we have some natural fireflies. I'm told they don't bite. In fact, they might not even leave that jar. Now, there's all sorts of gimmicky solutions like that one, but they don't really add up to much. We need solutions, either one or several, that have unbelievable scale and unbelievable reliability. And although there's many directions that people seeking, I really only see 5 that can achieve the big numbers. Now, how we're going to go forward on this? What's the right approach? Is it a Manhattan Project? What's the thing that can get us there? Well, we need lots of companies working on this. Hundreds. In each of these 5 paths, we need at least 100 people. And a lot of them you'll look at and say, they're crazy. That's good. And I think here in the TED group, we have many people who are already pursuing this. In fact, people had talked about it for a long time, but they could never simulate properly whether it would work or not. And so it's through the advent of modern supercomputers that now you can simulate and see that, yes, with the right materials approach, this looks like it would work. You know, it's got lots of challenges ahead, but it is an example of the many hundreds and hundreds of ideas that we need to move forward. So let's think, how should we measure ourselves? What should our report card look like? Well, let's go out to where we really need to get and then look at the intermediate. For 2050, you've heard many people talk about this 80% reduction. That really is very important that we get there. And that 20% will be used up by things going on in poor countries, still some agriculture. Hopefully we will have cleaned up forestry, cement. These breakthroughs, we need to move those at full speed. And we can measure that in terms of companies, pilot projects, regulatory things that have been changed. There's a lot of great books that have been written about this. The Al Gore book, Our Choice, and the David Mackay book, Sustainable Energy Without the Hot Air. They really go through it and I think can create a framework that this can be discussed broadly, because we need broad backing for this. There's a lot that has to come together. So this is a wish. It's a very concrete wish that we invent this technology. If you gave me only one wish for the next 50 years, I can pick who's president, I can pick a vaccine, which is something I love, or I could pick that this thing that's half the cost with no CO2 gets invented. This is the wish I would pick. This is the one with the greatest impact. If we don't get this wish, the division between the people who think short-term and long-term will be terrible, between the US and China, between poor countries and rich, and most of all, the lives of those 2 billion will be far worse. So what do we have to do? What am I appealing to you to step forward and drive? We need to go for more research funding. You know, when countries get together at places like Copenhagen, they shouldn't just discuss the CO2, they should discuss this innovation agenda, and you'd be stunned at the ridiculously low levels of spending on these innovative approaches. We do need the market incentives, CO2 tax, cap and trade, something that gets that price signal out there. We need to get the message out. We need to have this dialogue be a more rational, more understandable dialogue, including the steps that the government takes. This is an important wish, but it is one I think we can achieve. Thank you. Thank you.
Thank you. Thank you. So if this doesn't work, then what? Do we have to start taking emergency measures to try and keep the temperature of the Earth stable?
Yeah, if you get into that situation, it's like if you've been overeating and you're about to have a heart attack, you know, then where do you go? You may need heart surgery or something. There is a line of research on what's called geoengineering, which are various techniques that would delay the heating to buy us 20 or 30 years to get our act together. Now, you hope, that's just an insurance policy, you hope you don't need to do that. Some people say you shouldn't even work on the insurance policy because it might make you lazy, that you'll keep eating because you know heart surgery will be there to save you. I'm not sure that's wise given the importance of the problem, but there's now the geoengineering discussion about should that be in the back pocket in case things happen faster or this innovation goes a lot slower than we expect.
Well, Bill, I suspect I speak on behalf of most people here to say I really hope your wish comes true. Thank you so much.
Thank you.
Super.